Okay, we were at some point, we're up to this set of slides, and of course we were talking about class diagrams, but not yet finished. So I will continue and we finish all these diagrams to model the system. And recall this a little bit, right? Where were we? Actually, we were part of this system modeling, requirement and system modeling topic, in which actually we make use of UML diagram, okay, the unified modeling language, in order to capture, model, and represent those aspects of the system that you would like to design and develop as part of the project. And we already, for the system modeling, right, we already discussed that there are quite a number of perspective that we can model, and each different diagram would serve and answer different perspectives. So you may need more than one diagram, because then we want to model different aspects, okay? Such as the context, the interaction, the structural, and the behavioral aspects. These are the things we can cover by different diagrams of the UML. And we already discussed that we focus on in our project and in most of the system model and projects in our course as well. Use case diagram, activity diagram, sequence diagram, task diagram, and state diagrams. These are kind of key diagrams to represent the system. Actually, there are also architectural diagram and component diagram, which could be very useful too. We cover already the use case. Cover already sequence diagram, certain parts. We were partially, okay, in the class diagram, and then we will continue today to finish class, sequence, and activities. And then, okay, sequence diagram, remember these are how it is like, and these are, there also are synchronization, consistency among different diagrams that you have to be, to have a concern and to maintain these consistencies, such as we mentioned that the use case diagram and system sequence diagram, SSD, they have certain corresponding, very important corresponding. Okay. Okay, I think we were up to here, the system sequence diagram that we complete, and we show a lot in terms of the some of the, we discussed certain important examples. Then we were discussing class diagrams, in which it's a type of diagram that can capture structure and domain concept of your system. What I emphasize, okay, let me see where are important things I would emphasize. Sometimes, right, class diagram could be called, referred to as domain model, okay, conceptual model, and so on. And the main components in the class diagram for sure must be classes, and of course their associations. But remember last time we already discussed what are differences between object and versus classes. Okay, so we were talking about the class student, and maybe each of you as instances of the class student. Okay, and that means each of you is an object. Okay, and a few other examples that we discussed. So these are the important components, okay, I mean details or properties, yes, I should say, for an object. Okay, to recap a little bit, it is an entity, oops, object is considered as an entity, tangible or intangible, fine, in which in the application domain you are talking about, such as in the system you're modeling, it has certain role, right, in that application domain, and it has state. State means it has properties or attribute. These are defined as the state of the object, defined by their properties or by their attributes. Behavior represents the, actually in programming, represent the method, the function the object could do. So actually, we just want to represent object class behavior, but when we explain it, okay, that's it. Basically, identity means the ID. We treat every object as different unique ones. So in the application world, of course, there would be unique ID that can differentiate one object from another. Even everything is the same, but they are different by the ID. Okay, then the class means the template, the blueprint, whatever that you can consider as a kind of logical grouping of similar objects. Similar objects means they have similar set of attributes. They have similar set of behavior or functions and methods, such as each of you as individual object in my system of student AIT student system. Each of you have age, has name, has so and so, the same group of attributes but different values. Each of you can perform the same function as you as an individual object, such as change the name, update the grade, register more courses, drop some courses, and so on. These are the behavior. Then I group you because you have the same set of attributes, the same set of behavior. I group you into a class called class student. Okay, and then I define, right? These are the structure of every object that's supposed to follow the same thing. If you are object in the class student, that's the key thing. So we already talked about this, right? That the notation when you model class diagram. It would be rectangle with different parts. The first part identify the class name, list of attributes, and then list of functions or methods, or sometimes yes, operations. Okay. Sometimes when we want to make the diagram compact, we can omit some of these parts, such as we only show the class name in the diagram. Or sometimes you can show class name plus attributes. Sometimes you want a very complete and full version, you show also the operations part. But then you can increment to how much you want to show in the diagram for readability purpose and for communication purpose. Okay. Types of operation we already discussed, right? Important operations can be classified into these important types. That is constructor. It is an operation that is used to create new instances. When you define a class student, we may want to create many students, as many of you, as students object in my system. Then I need a constructor of my class student to create object A, and then I update information such as your name, your ID, and so on. I create another object B, I update your information into that object and so on. But first, to create, we call to construct an object. Okay. Query is another type of operation that get data, get attributes, value, return to those who ask. So it's the kind of operation that answer to the query, such as get name. That means it will return the name. Get GPA, it will return your current GPA. Get program of study, I mean, it will return which program of study you belong to. Okay, so I think you are familiar with the notation. Usually, most of the programming language in object-oriented programming language make use of dot notation. So it would be, if we have student object, student A as an object, we use dot notation like student A dot get GPA. It will return the GPA of student A. Suppose if you are student A, it will, this method operation for the query means to return the value of that attribute. That means this query means for reading data value, data attribute, and return. Update means, yes, make changes, right? So it could be student A, the same. I could name it like set GPA. Suppose I want to update the GPA. Set GPA 3.45, something like this. So it will make change, but this is just example, right? Different programming language may have different ways and different convention of doing this thing. Okay, then those are about class and objects. They are kind of independent, right? When we discuss object, we discuss class. They are not interacting with each other yet in my explanation. But actually, class may have association. This is the terminology in the object-oriented world. We call association, which means relationship that a class could have with another. But what does it mean? Actually, relationship could mean, when we say relationship of one class to another, actually it means a relationship of the object of the class. The class itself doesn't have relationship. When we say that student register for courses, okay, this is example of modeling relationship or association. The student class does not have relationship. Actually, it is a student object. The class itself is just a class. It's very static. But the dynamic thing is the object, not the class. But when we model by the class because we want to say that object within the class could have such a relationship with another object of another class. So in this case, to be precise, I would say a student object. Okay, register for a course object, right? When you register, you don't register for the class or the course as a class. You register for particular course object, such as ISDM course. This is an object. Natural language processing, that is another course object, and so on, right? There is no course class for you to register. It's just the object. course. Okay, but when we made model through the class to say that, okay, we can have any object of the class student could register for any object in the course. Okay, the same for person. Here in this example, we model here that we have the person class and we have association, which is called is married to. So we want to say that a person object is married to another person object. This is kind of recursive association because an object of the same class has association with another object of the same class. Okay, but this is clear, right? This kind of model association. The same. Another example of recursive association here is employee. We have employee class and we could have association called managers, which means an object employee manages another object employee. Okay, and another example here is employee. This is kind of space management application. A class employee here, oops, and then class parking place. These two classes, we model the relationship to say that an employee object is assigned to a parking place. Okay, when we handle parking place in the office. Okay, what I skipped here. So now you understand what does it mean by association. So just think about it as relationship. Those who learn with me the DMM course, I think we already discussed something similar in the DMM when we model entity and relationship and so on. It's quite similar, okay? Modeling concept. But in entity relationship, we only focus on the data. We don't have, it's different from object-oriented modeling in which it also consider operation. In database, we only consider data model, not the behavior part. But that's just the difference. But in terms of the domain concept modeling, they are similar. Okay. When we describe association, we should also describe what is called multiplicity of the association, in which it gives detail of how many objects that the association that is described by the association, through the association, how many objects we can have relationship with. And let's look at the example. I think it's easier to understand. I would say maybe start with, okay, with the very first one. When we talk about a person and the association married to, in many countries and many culture, okay, mostly, I would say we have this concept, right? In one time, at current time, a person is married to another person. The multiplicity, or sometimes in the ER concept that we learn, it is called cardinalities. That means one person can marry to or is married to 0 or 1 another person. only. You may, for you, is 0 or 1. Are you married? No. So 0 or 1? 0. So you are married to another 0 person, right? Because you're not married yet. Anyone has number 1 already in this example? Oh, 2. Yes, me too. 3. Okay. So that means, suppose, let's say a person, we have a person object. Okay, if we talk about, remember we talk about this notation, we can have an object with this notation. So we can have an object, John. We can have an object, Julie. Okay, she is also a person. So it could be that John is married to Julie. Okay, I'm modeling an object diagram. This is an object model. A real object, John, is married to another object, Julie. Just 1 to 1, right? 1 John, 1 Julie, married with each other. There might be another object, Joe, person. If he doesn't marry, then there is no is married to for Joe. Nothing. Okay, he has no such association with any other person. Okay, that's it. So these indicate each association has the originator and destination, original and destination. Okay, we have an object associate with another object. So original and destination object, something like that. So 0 person may be married to another 0 person, that's fine. 1 person married to another person, that's fine. But 1 person object cannot marry to more than 1 person object. So we will not allow John to have also another is married to, let's say, Mali. So if you model like this will not be possible because then John is married with 2 persons at the same time. So these are not allowed from the model. So you may need to model this. For example, in your D-Health project, once you say that patient has an appointment with a doctor, how many appointments a patient can have with a doctor? 1 only? Patient. We may have class patient. We may have suppose I'm modeling very simple, right? You can make a very more sophisticated, but this is just to model a simple diagram first. Doctor. Has appointment. Actually, it should not be like this, but we will talk about this later. A patient has an appointment with a doctor. This is clear, right? 1 to 1, this is clear. A patient has an appointment with many doctors. Is it possible? Yes. Not at the same time, right? Yes. You can have an appointment today with Dr. A, tomorrow Dr. B, another day Dr. C. Why not? You may need to follow up even with only Dr. A. Today with Dr. A, tomorrow also with Dr. A, another day is also with Dr. A because your treatment is still not complete. Okay? That is for sure. A patient has an association with many doctors for the appointment. How about a doctor? 1 doctor, how many patients he may have an appointment with? 1, 0. 0 can be, right? But of course, 0, 1 can be, but also could be more. If you have only 0 and 1, I think you get a problem, right? You may not have enough work to do. So it could be that a doctor can have also appointment with 0 to many. The same patient has appointment with 0 to many doctor too. Okay, that's an example. So you could see here. When we say asterisk, it could be the same as in ER model, many, M or N, that's fine. But asterisk means wildcard, so it could be any number. So any number means 0, 1, 2, 3, 4, 5, 6, 7, 100, and so on. Okay, so what does it mean by this? A student register for many courses. You do. A course has many students register for, right? A course also has many. Yet, like we do have here, my course here has many, and the same for other courses. Okay. How about this? Product line contains one to many products. This notation say one ... Asterisk means one to many. So a product line contains one to many product, cannot contain 0, must be minimum 1. When you set up a product line in your factory, you must have the product line to produce at least one product. Okay. A product also read reverse direction. A product must be contained in exactly one product line. You cannot be produced by too many product lines. Your product belongs to exactly only one. Okay, employee is assigned to 0 or 1 parking place. We give a quota. You can have a parking place for 1 car maximum, 0 optional, right? Maybe minimum 0, you may not have a car, you don't need to get a quota for car park. I give you maximum just 1 car. You cannot drive 2 cars to work anyway, right? So 0 to 1 here, because some employee may not have a car, or we may have policy that we give car parking only for senior level employee. So not everyone will get a car parking. The same, each parking place, if it is 1 parking place, this slot, if it can be assigned, right? It will be assigned to 0 or 1. So this slot may be empty, not assigned yet, vacant. Or if it is to be assigned, only 1. Otherwise, we will have a fight, right? People will fight for that parking. So we don't make this clashing. Okay, so this is a way to model this multiplicity. Okay, and actually the way to define, you can use ... notation to start to say the minimum, starting from minimum to maximum. Could be any particular number, 0.10, 0.5, if you want, if you have real constraint. Such as sometimes maybe we want to say we allow you to register as many as course as you want, but maybe we have some limits. Let's say 20 course maximum. Then you say 0.20. Okay. And asterisk means any number. For a specific number, that is also possible, right? 5, number 5, that's fine. You constrain 5 multiplicity. Okay, so these make a more complete picture for one small application or system, for student registration system. So we have the class in this. You can see we model domain knowledge, domain concept of the system, in which domain concept consists of student, course, faculty, But the cost itself actually should not be there. It is called cost offering because we offer a particular course in certain semester. And when a faculty teach, it doesn't teach that course. Actually, it teach that course offering because maybe this semester ISDM is offered by me. Next semester ISDM offered by another teacher. Then you need to, this model allows different offering in different semester. Okay, anyway, you can see here, student register for so many course offerings. One course offering can have also many students register for it. Okay, and one course offering actually is for one particular course. But one course, you can have many offerings. Even the same semester, we can have 10 offerings of the same course, divide by like section, right? In big university, when you have 1,000 students, I cannot teach 1,000 students in one course. The same course may be divided into 10 sections of 100 each, okay? Okay, and then the same. So let's look at this later on. Then another important thing we need to discuss is called associative classes, because sometimes an association may have attributes. It's not that doctor make appointment, a patient makes appointment with doctor. But in this make appointment, I want to record some details such as the date, the time, and some pre-symptom I am facing. I may want to record that in the relationship in the association. And that is done through what we call associative class so that we can define and model attributes of the association. Okay, let's look at an example. If we model this student and course association like this in a simple way, student takes course, a student takes a course, right? Also many to many. But when a student takes a course, we want to record, it's not just that you take the course, right? We want to record when did you take it? This semester, that semester, and so on. What grade did you obtain from the registration that you made, right? So there are information or attributes or data you want to record the value, okay? And this one, this is the association. Here, the association text. So here is the associative class. Is the class for the association to record details, attributes, basically. So you can define attributes you want to record, the term, the year, the grade, whatever. And the notation, yes, I need to. The notation, of course, you can see that there is the line from class to class that is for association, but then when it is associative class, you will see this. So this say that this course, this class registration is an associative class for that association with the dotted line, starting from the association itself. Okay, so back to okay, I'm not talking about stereotype. Back to our patient story. G health. The same when we say that, make it too big. So it will be like this. We can define it this way. And then you can record appointment date, time, whether it is confirmed or not. Some description of symptom. And so on. This is only example, okay? Because the real detail is for when you analyze from the requirements, and it could be totally different from what I gave here. This is just to show you as example and some idea. So this could be the thing, right? Patient has an appointment with the doctor, then we need to record details of the appointment, right? When we are appointing, when is the appointment date, time, schedule, whether it has already been confirmed, whether it has some short description of the symptom, because when you make an appointment, usually the nurse who screen some symptom detail will ask you, right? Oh, what is wrong with you? So that she can note this information down for the doctor to read before meeting with the patient and so on. Okay. Abstract class, concrete class. Okay, this is very object oriented. I will just talk about this quickly. Okay, in some object oriented, not in some, in the object oriented concept approach, there is a class which is called abstract class, and it would be defined like this in this notation. Okay, this is abstract, mean that actually it is defined for the purpose of modeling, but actually there will be no objects of that class. It is a class that has no objects, no real objects. We will talk about generalization, yes. In class diagram, there are important concepts which makes a class diagram and object oriented very powerful. That is the concept of inheritance through the modeling of subclass, superclass relationship. Actually, we can make the relationship among classes not only by the association. Association means like some class has certain form of relationship, like doctor appointment with patient and so on. Student take courses, employee work for a company. These are association, general association, which could have some meaning in the application. Another important type of relationship is called generalization, or sometimes to be easy to understand, it is subclass, superclass. We can say that this class is a superclass of another class, meaning that it is more general. Such as here, patient is a superclass of outpatient and resident patient. Usually in a hospital, you have two types. Patient who comes and then go back home. Patient who comes and then stay, right? You get admission to the hospital because of your condition may be too serious. So that is, sometimes it's called inpatient, sometimes it's called resident patient, but it means the patient who stays and has a room, has a bed in a ward. Outpatient comes back and comes and go back. So in this example, we can see a few things. This is called superclass. It is the class that has subclass. These are subclasses, two of them. notation we use this small rectangle. Usually if it is general association, is just a line, a solid line linking one class to another. That is association. But then generalization or subclass superclass relationship, we will use this triangle symbol. And this triangle will point to the superclass, okay? You need to pay attention to the way to draw it, okay? So this means this is superclass patient and it has two subclasses, out and resident patient. And when we say here, this is abstract, means in the system here, in this model, we will not create patient object. We will only create outpatient or resident patient object. If you are a patient, I should know, I should be very exact whether you are outpatient or resident patient. I will not say you are just patient, okay? In my model, it's too vague. I want to be very precise and exact on modeling you. So that's why we call this abstract, and others are just normal class, or we call concrete class or abstract class versus abstract class. And then another thing why this is important, because with the subclass superclass relationship, or it is called generalization relationship, it allows us to do what is called inheritance. That is, anything that the superclass has will inherit the properties and behaviors, operations to the subclasses. For example, we say that patient should have patient ID, patient name, admit date. These three attributes are defined for the patient. When we see outpatient, we have check back date attribute. When we have resident patient, we have date discharge when you leave the hospital. So inheritance means that anything belongs to the superclass will inherit. It's like you are children of your parents, you inherit certain things from your parents, right? The same. Everything here inherit through the subclass. So meaning that if you are outpatient, you will have patient ID, patient name, and admit date. If I am resident patient, I will also have these three attributes inherited to me too. So with this way, the model is very compact. Okay, because we can define something from the superclass, and everything that is in the subclass level will automatically inherit those properties. The same also operations will also inherit. And relationship or association will also be inherited too, such as patient will be treated by physician, right, or doctor. Oh, in outpatient and resident patient, they do have this association as well. Every patient, either outpatient or resident patient, will have association treated by with the physician. Okay, these also, everything will be inherited from superclass to subclasses. And that is why this is one of the very powerful modeling mechanism in object-oriented. But here, this is interesting. Assigned to bed, resident patient has a association assigned to bed to the to bed object. Outpatient will not have. because this is very explicit and specific association that is for resident patient only. Okay, but this one is different, right? This one is on the superclass level, so subclass will have, but this is on the subclass and specific level, so only resident patient will have this relationship association. Okay, if you're outpatient, sorry, you don't have that. Okay, questions so far for this? Okay, so okay, when we have generalization, that means the concept of super class having many subclass, to be sub 1, subclass 1, subclass 2, subclass 3. And we call it class hierarchy, because actually this subclass relationship can go any level, down, down, down. Think about it as your family tree. You have ancestor, your parent, yourself, you may have your children, and then grandchildren, and grandchildren, and grand. This is the same thing, okay? So you can even have all this in any level, and it works the same way. Attributes and operations from superclass inherit down to everywhere. If you are here, this class sub 2 will give everything down to A and B. Sub 3 will give everything down to C, D, E. But everyone here in this diagram will get everything from the super, right? In terms of inheritance. And you don't need to share, okay? Everyone get equally, don't worry. It's not like inheritance of properties or money or something. You get equally. Okay, but then, okay, what is explained here in this slide? Sometimes when we have many subclasses, we could define whether the subclasses are overlapping or not, disjoint or not, complete or incomplete. What does it mean? Let's have a look. Okay, let's look at this example. We have student, graduate student, and undergrad student. When we have, we need to define. First, what do you think? This grad student subclass, undergrad student subclass, are they overlapping or are they disjoint? You choose one, okay? You cannot have both. If they're overlapping, they're not disjoint. If they're disjoint, they're not overlapping. What does it mean? It means that if I am if you are in this system of university, right, in one same university, you need to define. If we have student A, a graduate student, we need to define, oh, okay. We may say that we model it as disjoint, right? You cannot be a grad student and undergrad student at the same time in the same university. But I believe right now, maybe you can, if you do a part-time program, you can study master degree here. Suppose it's not AIT, okay? You may also enroll for undergrad program in laws or in business, maybe, right? It depends. So you need to model. And to model it correctly, it means you need to get the requirement, right? Whether in the university you are modeling this diagram, it allows grad and undergrad to be at the same time or not, okay? And Complete or incomplete means that is it possible to have a student who are not graduated or not undergrad? They are high school, maybe, right? So that means this inheritance in this level, the subclass in this level is not, it is incomplete. If there are some students who may not be both grad and undergrad. Okay. Abstract. Okay, I will skip this. It's very much the or concept. Okay, but this is more important. Another way, another type of association or making relationship among classes. We already see two types. One is just association. Two types of relationship in which you can have associative class. Another types of relationship is generalization. The third one will be aggregation and composition. Sometimes nickname, easy nickname for these things, for this third type is part of. We want to model that a class is part of another class as kind of a component of or something. Okay, let's have a look. Here, part of is actually referred to by aggregation, in which it is a part of relationship between a component object and an aggregate object. And we use white diamond to represent it. Composition, on the other hand, very similar, actually, is a stronger version of aggregation. Sometimes people may not distinguish. Okay, sometimes they just model them as the same thing. Okay, but sometimes if you want to be to make very precise, accurate modeling, you may need to distinguish them. Stronger version of aggregation such that a part object that belongs to only one whole object, and the part lives and dies with the whole. Okay, we will look at the example, and we use black diamond to represent. Okay, such as this is white diamond, so this means aggregation. A university is composed of administrative unit and school. The school is also composed of department. Okay, so we use white diamond attached to the aggregate. Okay, and these are the part. These are also the part. Okay, this is the aggregate. Okay, you also need to notice that when it is generalization, you never have multiplicity. You never say star 1 0. No, you don't. Then you cannot do. Okay, because it doesn't work that way. So, but in association, you have to define the multiplicity, right? In the part of, you also need to define, because then it can tell you that, oops, for example, a university has one to many administrative units, in which it could be like accounting office, HR office, payroll office, procurement and purchase office, IT office, and so on. These are administrative units. And also a university would have one to many schools, such as School of Engineering and Technology that you belong to, School of Environment and Research, the Resource Development, and so on, School of Management, and so on, right? So this has to be defined. And you see, it's always administrative unit belong to only one university, right? An office of procurement, that office belong to just IT. But maybe in the future, one office may work for 100 universities if they are outsourcing model or something. Anyway, that can be possible too. The same here, a school has many departments. Asterisk means 0 to n. So maybe some school may not have department, just the school is not big enough to have many departments. Okay. And this is general association, right? A school housed in or located in a building. A building has many rooms. And you see this is black diamond. Because a room itself cannot stand without a building. A room needs to be with a building. Okay, but maybe a department, a school, the department, we may have a department that doesn't belong to a school. We may have a school that maybe don't belong to a university or something. I mean, to make the concept a little bit loose. But that one is a little bit strong and fixed. Okay. All right. And that's all about the class diagram. Anything? Question, comments? If not, I move further. The remaining are just some research statistics of how software engineer make use of the diagram and sketch diagram and so on. I will skip, okay? We will have time, and if you have time, we talk about that later. But I have some important thing to complete, so let me move, in which there are not very many now. Okay, then let me move to another diagram, which is activity diagram. Is part of what? Interactive behavior or what? Static, or what does activity diagram belong to? Which category? Can someone help me? In the UML diagram, you remember the class hierarchy of UML diagram, right? Where activity diagram is search and find me. Come on, quick. Everything is with you too, right? Not only I do have the information. Where activity diagram belongs to. Okay, find it. Yes, anything you find? Can someone tell me? No, you cannot locate that slide to answer me. Really? Oh, okay. I think you may not have even ever downloaded the slide for your local copies. Maybe I should have more assignment, homework, or things to make sure you do that. So, or even maybe, okay, here we are. Even today, we already recapped that. Where are we here? Oops. It is used for modeling structure of the system, behavior of the system. So it's under the behavioral diagram, okay? While class diagram here, structure diagram, sequence diagram here, you see the notation. We also use class hierarchy notation for this diagram, so that you see the topmost is the superclass, which is diagram. Then we have subclasses. The first level subclass is behavior diagram and then structure diagram. Then under structure behavior diagram, we can decompose into activity diagram, interaction diagram, state machine diagram, use case diagram, and so on. Okay. Okay, then let me switch back to the activity diagram. This is actually how activity diagram look like. Okay. I want you to go away. Some of the notation I explained a little bit first, but also why do we need and use activity diagram? Can we make it disappear? This is always my float meeting control. Okay. Actually, we normally use activity diagrams to show the process flow, business flow of a certain activity. And usually it should be for a certain use case as well. You're not making a flow of something that is not relevant to what you model. You need to select some use case and so on, so that you define a flow, how it works. And it can show parallel, alternative behavior or process flow or activity flow, as I said. And usually, as I mentioned, used to show the logic captured by a use case or some usage scenario to model detailed logic of a business rule or business process. Okay, so a little bit about activity diagram. When should we use activity diagram? You don't need to model everything by every model, okay? As I always say, we try to make minimum documentation and modeling as possible. Something that is very clear, very understandable. Maybe you don't need to draw a diagram of every possible thing, okay? We choose activity diagram where we want to depict the flow of control from one activity to another. So actually it's a flow of one activity going to the next activity, and so on. And it is used, as I already mentioned, for use case analysis to understand in more detail about actions detailed in the use case. Okay, workflow, business process already mentioned. we can see the sequential and concurrent steps. We can see that something can be done in parallel. Something has to wait. As a sequential, you cannot do things in parallel, right? You have to wait for step activity A to complete, then you do activity B, you do activity C. But sometimes if you can parallel means A, B, C, you can do parallelly, maybe by different people, by different program components. Okay. All right. Let's look at this example of activity diagram for customer order process. And what is, okay, let me explain all first the components you see in that diagram. Okay. First, you see for sure activity, and usually it's represented by a rectangle, okay, to represent a certain activity. A branch means that you will see a diamond to branch conditioning, okay, that we can go here or here, okay. And then a merge, that means two activity merge to another, merge together. A fork, one activity splitting into many parallel activities. A join, several activities join back at certain point, so that we need to wait or do some activity later on after everything finished in the parallel activities. Swim lanes, this is the columns that divide all those activities by different components, unit of system, or people, actors. So let's see here. These are the swim lanes. You can see it's like, are you a swimmer? Any of you like swimming? No? Do anyone a swimmer here? Have anyone has never been inside AIT pool? Tell me. Never. Anyone has already been swimming in AIT? 1, 2, 2 only? 3? Not in AIT, not yet. Maybe Siam Park or where? Where did you go for swimming? Pattaya. Okay, even further, AIT pool is no fascinating. No fancy. We need to go that far to Pattaya. Yes. Okay. Anyway, doesn't matter wherever, right? But if you are swimmers, usually in the swimming pool there are no lanes. These lanes happen only if you have a race, right? If you ever watch kind of swimming competition, we have a real lanes. We call swim lane because we don't want swimmer to cross the others, right? And then interfere with the competition. Okay. But you know, Piriya, one of our PO, he is a swimmer. I mean, he competes, contests, or in the past he really joined many competition, and even now he's still very active in this swimming. Okay. Anyway, when I was one side story, when I was a student here, I'm not sure it was master or PhD time, but we do have AT mini Olympics, right? Did you join AT mini Olympics last year? No. Okay, you should next time, right? Playing sport is good. Sometimes you relax and forget something. I was there as one of the competitor in the swimming. It's representing school or program as of now when you compete. Country. Oh, okay. That time I think it's by school, by program or something, not by country, because some country maybe have small number of students, right? Okay. I got the 3rd place, so I got a medal or something, but there were only 3 swimmers too. Okay. Anyway, okay, these are swim lanes. Sorry. So we need to divide the lane for different units in the system or different components, whatever you call, right? Or actually, activity diagram or this kind of swim lane diagram can be used in the business modeling too, not only in computer programming system development model. You can use and you can see, you can apply it to real business model, okay, business process modeling. And if it is applied to business process modeling, this can be the units or department within the business. Because we can see the flow of the work of a process and who are in charge, which department office units are in charge. But if in our system, who are in charge would mean here module in a computer program system. But first here, this is to understand the current process, which could be manual or could be computerized process. Here we talk about customer order process. So it starts from here. Let me remove everything first. It starts from the customer service unit. Receive an order. Okay. So you see this is a starting point. This dark circle there is a starting point. And okay. Once it starts, okay, to this activity, receive order, then you see here, this is notation for forking. Forking means we are doing multiple parallel activities at the same time. So you can, okay, you go do this, you go do this, and everyone do at the same time. No need to wait for each other. So once the receive order happens, we fork to pool available inventory to be responsible by fulfillment unit. Fulfillment unit check whether there are available items for the purchase order in the inventory or not. At the same time, the accounting unit prepare invoice. Okay, then accounting unit cannot do anything, it finished. Wait until something happened first. So on this side, after fulfillment check for availability, then of course there is a condition, right? This is the branching with the diamond means condition similar to the flow chart. If there are some items that we don't have, missing, we don't have available in our stock, so we need to prepare back order for the user, for the customer. But otherwise, then that means this is possible, right? There are otherwise for some items that you have available in stock, you continue to wait until this. And when full back order inventory is done, okay, then we merge this together and send the order. Send the order means kind of deliver, make to the delivery. The fulfillment means to handle everything of this, okay? Then in this case, we check whether from the purchase order, user requests express service or not, express service of the delivery, or otherwise using regular service of the logistic. So if request to express service, we send by express mail, otherwise send by regular mail, and merge them to combine point together. Then when the sending is done, right? It's done from the fulfillment, then the invoice can be sent to the customer. And then when the payment is received, we can also proceed with the receive payment activity. And then when everything is done, go to the close order activity and have at the last the black circle for ending. So these activities start to end, right, with the black circle and black circle to tell that, okay, the whole process starts from here and ends here. So you could see that there are activities. There can be branching where you can do parallel process or activities. There can be merging, forking, joining, and there are swim lanes of many either organization units or computerized modules in the system. Okay, so don't forget, okay, yesterday I already mentioned product backlog, sprint retrospective, sprint review, and many things, right? Make sure that in your product backlog, product that I mentioned yesterday, you need to make, right? In your product backlog, when you would design, develop certain story or use case, you include the task of all this design. What is going on? Oops, okay. You include a task of all these diagrams, modeling, okay? Use case you already show, but verifying, as I said, accepted by the PO is another question. Choose the use case and user story, right? What happened? Okay. Choose the user story, make sure it's part of the sprint, of the current sprint, to model the class diagram, to model the system. There is no step order, right? Okay, this is just to list. It doesn't mean you have to do this first and second and third, okay? You decide and plan. Make sure to model these three things for important, high priority use case and user story. Okay? An interesting one. Okay. I think these are all, and let me finish by bringing back this diagram at this slide one more time. I think this is to explain the relationship of different diagrams we learned so far. But I think we already discussed this slide, but this is to summarize, okay? We learned the class diagram. Okay, this is the class diagram for making domain model. We have use case model. For use case model, we have use case diagram. Okay. From a use case diagram, you will have system sequence diagram to identify steps, right? For system as a black box. And this is for the use case description, actually the text description. Okay. And these are in the design model of detailed sequence diagram. And from this sequence diagram, you could see that actually every project start from use case for sure. You start from use case to know the overall project things. From the use case, you can do number 1, number 2. Actually, number 3 means activity diagram. You could also do. And then number 4, you can do class diagram for sure. Once you have class diagram, you have the main classes, such as here, it's about making purchase. We have class sales, class register, product catalog, and purchase order, many more, okay? From these class diagrams, you should be able to also model detailed sequence diagram of some process, some use case as well, okay? So number 5, this will be possible. But you don't need, I mean, for class diagram, you will have only one diagram for the whole system. Use case, how many diagrams you will have? One, right? One diagram for the whole system. System sequence diagram, how many? The maximum you could have is one per each use case, right? This is use case. This one use case will become one sequence diagram. Modeling this. Okay, this can be modeled by another sequence, but you don't need to have, okay, what I will say is that number 1, maybe I should, sorry. Okay. Diagram needed. I mean, actually, we are doing the modeling. And actually, we need diagrams to do proper modeling. The very first one, for sure, you need use case diagram. One only. Number 2, some selected use case. You can make system sequence diagram, right? And one for a use case, usually. But if there are many exceptions in your use case, there are a lot of exceptions. You may have more sequence diagram, something like that. Number 3, class diagram. And again, one only. One for the whole system. Number, yes, we need activity diagram too. You don't need both at the same time. Sequence diagram and activity diagram. You can select for this situation, let's use activity. For this case, let's use sequence diagram and so on, okay? Choose the right model for the right, choose the right diagram for the right modeling job you are working on. No need to have every single use case another particular diagram, okay? Number 4, maybe a sequence diagram. I would say detail. Okay. For some use case. So the must have for sure, this one, you cannot omit. The number 2 and number 4, they are kind of optional for some selected scenario and use cases, okay? Okay, that's a summary as of today, okay? So thank you everyone, and let me